Do you ever wonder about air quality when riding a bike or walking near busy roads and freeway traffic, or just around the neighborhood? Does proximity to cars matter? To investigate, I procured an air gradient air quality monitor. This device includes sensors that measure particulate matter, volatile organic compounds, CO2, and nitrogen oxides that contribute to air pollution. In normal use, your home monitor sends its readings to an internet website which shows air quality data. That red spike indicates my neighbor using a blower in his yard, creating a bit of dust. Although this version of the air gradient monitor is intended for outdoor use, I wanted to take it with me on bike rides and walks to see if there's any air pollution along my route. An easy way to do this is to link the monitor with a Wi-Fi router and collect air quality data on an old Android phone running some custom data collection software I wrote in Python. The phone also provides GPS logging along my route. I cobbled together the pieces required and built a simple caddy from scrap wood. This camping battery supplies AC for the 20-year-old Wi-Fi router and USB power for the monitor and phone. This caddy fits in my bike's tote crate and is secured with bungee cords. A piece of foam keeps vibrations down. A test ride proves that the phone collects data properly. I then ran the data through some custom Python code to generate a map of my route, proving this concept works. However, this configuration obviously isn't practical. The next step is to get rid of the Wi-Fi components and to use the Air Gradient's built-in Bluetooth low-energy interface. This version of the Air Gradient monitor doesn't support this feature yet. Being an open-source project means you can modify its code to add features. And that's what I did. I downloaded the code and added a Bluetooth LE data logging feature. On the phone, I used Nordic's NRF Developers app to connect to the monitor and save the logging data on the phone. Using a small USB battery to power the Air Gradient lets me fit everything into a bike bag or its shipping box. After riding around, the log files are copied from the phone and converted by Python code into a CSV file to view in a spreadsheet and to generate a mapping visualization. Here's a visualization of a ride that follows the bike path along Interstate 5 and cuts across Solana Beach and then goes north along Coast Highway. At the top left, I can cursor through and select the various sensor readings, and they're highlighted on the map. The blue is just the route, and then anything over a threshold level is overlaid just so it's easier to see in a video. For CO2, what's interesting is down here, that is probably from me breathing. There's a slight tailwind going up this hill, and I think I catch up to the wind, and I'm just in my own cloud of funk. However, the volatile organic compounds really triggers, and that's probably due to being near a swamp. And this is late February, but it got warm a few days, so the swamp was probably, this is just organic matter. Index number there just indicates 100 is about an average for a day, and then this is just tells you there is a change. So along the coast, you can see it's actually, there's probably kelp, anything by the beach, usually may be decaying. I also call this an electronic nose because if you smell something stinky or beachy, this will probably pick it up as well. So as I continue to see the higher concentration, notice I rode through our campground down here, and some of these are near the bathrooms, or in this case here, this is by a restaurant row. This portion of the lagoon sometimes is funky, I can tell. Up here, there's restrooms as well, or RV dump station. As far as nitrous oxides, nitrogen oxide compounds, there aren't any. And particulates, and corrected PM, it was a pretty clean day, which is what you want to see when you're biking. All right, here's another ride that goes down to Solana Beach. Notice the route looks like it's in the ocean, but actually I'm on the beach during low tide. What's interesting here is that at low tide there's probably exposed reef, and then there's kelp washed up on the beach, so there's a lot of organic material. And again, it looks like we're picking that up on the volatile organics. Nitrogen oxides, a little extra here. I don't know if it's because we're near a parking lot, but that's not that much. But what's interesting is the particulate counts. So these are the small particles that are in the air, and that number denotes the micron size. And the count, usually when they're higher, just means there's more particulates in the air. We're getting them from the small size down to the 1 micron to the 2.5 micron. And even our corrected, which is the air quality we're usually concerned about, is a little bit high for a nice beach day. And I'm wondering if being on the sand itself there's ocean spray that gets blown inland, and we call it, salt air or something like that. But there might be, in fact, this is just seeing that there's ocean particulates in the air right there by the shore. Here's my fanny pack fashion accessory, ready to walk around the neighborhood, measuring air quality. The tape on the USB battery keeps me from yoinking the cable. Here's the walk I went. The CO2 is actually, I think I walked inside the thrift shop, and inside a building, your CO2 is probably going to hit 650 maybe. Yeah, that looks about right. For volatiles, again, in the campground, there's a bathroom up there. Some parts around town, I'm not sure what that is. Could be gardening, fertilizing. That's Glen Park. No nitrogens. But there are particulates again, and that's that path there, that red one, that's walking on the beach towards Tower 18. So again, right by the ocean, you're picking up some spray all along there, and that's what this is showing me. That's all for today's science experiment. I'll continue collecting data while getting some exercise.